Pluto used to be considered a major planet, but later was reclassified into something called a dwarf planet. Something too big to be an asteroid, but too small to be taken seriously. How rude. But recently, scientists began to discuss the mystery surrounding one of Pluto's moons. It turns out it might be even cooler than all of us. It might be a double planet system. Pluto is residing in the distant Kuiper Belt. It's a vast area in our solar system, like a big rocky suburb beyond the orbit of Neptune. It's filled with small icy objects, similar to Pluto, called Kuiper objects. They're leftovers from the early days of our solar system and give us clues about how it was formed. It's where many comets come from. You already know that it's small, but it's remarkable just how small it is. Pluto has a width of about 1,400 miles. It's about half the size of the United States and smaller than our moon. Pluto's atmosphere is very thin and composed of nitrogen, methane, and carbon monoxide. Stinky. It's also very cold there, with average temperatures being around minus 390 degrees Fahrenheit. Its orbit around the Sun looks like an oval, and 1 year on Pluto takes around 250 Earth years. Pluto also shows a strange and unusual retrograde rotation because it's tilted on its axis, which means that it spins on its side. If you were standing on Pluto, you'd see a lot of high icy mountains, valleys, plains, and craters. The Sun would be very dim and far away, and it would always look like twilight. It's a colorful planet, surprisingly. You would see a rainbow of pale blues, yellows, oranges, and deep reds. And the most adorable fact about Pluto is its famous heart, called Tombaugh Regio. Pluto was discovered super late in the 1930s, later than the rest of the planets. Initially, we thought that it's the 9th planet in our solar system. However, the more we explored the Kuiper Belt, the more we realized that it's full of these medium-sized objects. We found 4 more little planets just like Pluto: Eris, Ceres, Makemake, and Haumea. They all shared the same characteristics. And that's where we figured out that Pluto belongs to another family and created a category of dwarf planets. There are a couple of differences between these two categories. The first obvious difference is size and mass. Major planets are much bigger and more massive. They also have to be spherical, while dwarf planets might not be perfect spheres and might have weird shapes, like an egg-shaped Haumea, for example. And just like a regular planet, a dwarf planet orbits the Sun, but it doesn't have a clear orbit. Its orbit is full of debris and random objects. These are the only differences between the two. Well, as you can imagine, the reclassification sparked quite a controversy. People even made up a new term, Plutoed, which means downgraded. But although it might be sad that Pluto isn't a major planet anymore, we can look at it like a story about finding your true family. And finally, while standing on Pluto, you would see its 5 moons: Styx, Nix, Kerberos, Hydra, and the most mysterious one, Chiron, also pronounced Charon. So you can pronounce it however you like. I'm going to go with Charon. Now Charon is Pluto's largest moon. It was discovered in the 70s thanks to NASA's spacecraft called New Horizons. The spacecraft took a picture that revealed a moon with a strange and fascinating huge red-brown spot on its surface. It's a vast canyon dwarfing the Grand Canyon. It seems that both Pluto and its moon can boast interesting formations on their surface. The thing about Charon is that it's very big for a moon. It's about half the size of Pluto. This makes scientists wonder, could it be that Pluto is a double planet system? The center of mass, or barycenter, of Pluto and Charon lie outside of Pluto. Normally, with planets and their moons, the center of the planet itself should be the center of the mass, with the moon orbiting around it. But in the case of these two, it seems like they orbit each other. Binary objects are quite common in the universe. These cosmic pairs form just like our moon, from giant impact events. But double planets are exceedingly rare, and we haven't discovered any double dwarf planets yet. So, if it's true, then Charon is actually the 6th dwarf planet, and that would be our first binary dwarf planet system ever. There's also another candidate, the dwarf planet Eris and its moon Dysnomia. The solar system is full of mysterious and fascinating moons. So fascinating that some of them might not even have actual life on them. We've been talking about microscopic life in space for a while now. The debates about whether we found some organic fossils on Mars or not have been going on for decades. With the development of our technology, we're finally getting onto something. Meet Enceladus, who has stolen the spotlight since NASA's Cassini probe arrived there. Enceladus is covered in a sort of snowy blanket, which is why it's so unusually bright and has some snow-covered craters. It's small, only about 310 miles, and is mostly composed of simple rock and ice. But in 2004, we found plumes of water bursting out from this moon's south pole, which means that there's liquid water beneath this moon's icy surface. It's probably because of Saturn and its other larger moon, Dione. Their gravitational dance creates tidal forces that keeps Enceladus warm and lively. All this means that Enceladus is now a top candidate in the search for life within our solar system. Of course, life requires more than just water, and we won't find any animals there or anything like that. But we might find some microscopic organisms, and that's awesome too. In fact, Saturn is winning the lottery when it comes to life candidates. For example, scientists have a wild idea that Titan, another of its moons, might be home to extraterrestrial life as well. Titan is a frosty moon, chilling at about minus 290 degrees Fahrenheit. Surprisingly, it has some lakes on its surface. But don't imagine your typical water bodies. These lakes are believed to be filled not with water, but with liquid ethane or methane. Back in 2005, NASA discussed that there might be life munching on chemicals like acetylene or hydrogen in Titan's lakes. And then, in 2010, NASA investigated this moon some more. They found missing hydrogen and acetylene on Titan's surface, hinting at the possibility of something eating away at these substances. That's why some scientists dare to imagine methane-eating beings in Titan's freezing lakes. Moreover, they suggested that if these creatures exist, they probably have much larger cells than animals on Earth. What we could find there is something much bigger than a simple microbe, even something like a small animal. But Saturn isn't the only lucky one. Triton is Neptune's biggest moon. And you guessed it, it's another life candidate. It's an icy world with frozen nitrogen all over its surface and a crust made of water ice, again, super chilly. However, Triton is a hotspot for geologists because it's one of just 5 moons in our solar system that likes to show off with its active geysers. It's shooting nitrogen gas up into space. That would be a cool show, if we could see that. These geysers mean that Triton has some secret source of warmth, which means that, just like with Enceladus, there might be some liquid water underground on Triton. And if this cozy spot for life does exist, we might find some organics there. Unfortunately, sending a mission to explore these celestial bodies isn't easy. The only spacecraft we've sent so far was our Voyager 2 in 1989. We need more time, money, and technology to develop spacecrafts that would be able to travel far and investigate the area beyond Mars. And even if we do, it'll take decades for this spacecraft to reach these places. In any case, let's hope that during the 21st century, we'll finally be able to fully explore our solar system and all its mysteries.
This is Neptune. The next stop is Pluto. Stand clear of the closing doors, please.
One day, with top-notch future technologies, one stop from Neptune to Pluto won't seem much further than Times Square from Bryant Park today. There are huge ice mountains on Pluto, valleys that go further than your eyes can see, 160-mile large craters, almost as big as the largest one on Earth, and no life. The reasons are obvious. The long distance between Pluto and the Sun guarantees freezing temperatures on that dwarf planet. It also ensures a trip of a few billion miles. Plus, it's smaller than the Moon, so it would get crowded very soon if people started dwelling there. Still, there's one reason which makes life there not that far-fetched. The Sun has a lifespan and cycles within it. Our solar system used to be nothing but a cloud of gas and dust. As a result of a gravitational collapse at the center of this cloud, the gas and dust started gathering in specific, denser places. These pulled more and more matter as time went on, and something called conservation momentum made the mass start rotating and heating up because of immense pressure. Later, there appeared a disk similar to what Saturn has, but it was made of entirely different substances. And right in the center, there was the ball that eventually became the Sun. A protostar is a young star that's still gathering its mass, and that's exactly what the Sun was before the temperatures and pressures inside of it lighted up its core. Millions of years later, it became the Sun we see every day. But it won't stay this way forever. It will heat up even more and eventually get bigger and denser, turning into a red giant. It may one day get big enough to swallow up Venus and Mercury. Chances are, it might swallow even planet Earth. Even if it doesn't devour our planet, the Sun might get close enough to touch us. Well, if this happened, life on Earth wouldn't be possible. But then, in just a few minutes, the Sun loses about 40% of its mass and shrinks about 10 times what it used to be. It's not as bright, and indeed, not as hot as it used to be. By this moment, Earth will have already been deserted. People might want to start traveling around space, or settle down on another planet where life is sustainable, like the exoplanet Kepler-62f, which, by the way, is even bigger than Earth. While all of this was happening, Pluto was changing. Before, every resource was frozen inside of the dwarf planet. Water, gases like methane, carbon monoxide, you name it. But as the Sun was reaching its peak luminosity, Pluto was slowly warming up and losing a lot of what it had to the vastness of space. At the same time, an atmosphere formed up. If the atmosphere gets thick enough, it would create favorable life conditions. Then, instead of spaceships, a tiny percentage of us would be able to set up colonies on the dwarf planet. The temperature is comfortable there, almost t-shirt weather. It even resembles Earth a tiny bit. Canyons filled with water, beautiful endless fields with trees, and lots of space to run around, and mineral water pockets on the ground, good enough to drink. Pluto's rotations are different than Earth's. An Earth day is 24 hours, and sometimes it still feels like it never ends. But on Pluto, a whole rotation around the Sun takes 153 hours, because it's pretty far away from the Sun. After several hours without sleep, we get tired and our eyes get red. It means we'd have to take several naps throughout the day on Pluto. A year on Pluto equals 248 Earth years. Unless we come up with some sort of technology to get us to live that long, our entire lifespan would be less than half a year on the dwarf planet. So, houses on Pluto might need to be equipped with cryo chambers. Whenever you feel like dreaming for a long time, you jump in it and wake up 50 Pluto days later. On the dwarf planet, there are also seas and beaches. So it's just like a tiny Earth, far away from the actual Earth. The food on Pluto could be tastier. We might find a way to make the ingredients more savory and even try to grow them faster during the trip. You plant a carrot, and 2 days later, it's ready to be in your salad. There could also be new ingredients for our salads on Pluto. Maybe 2-meter-tall mushrooms we've never seen before. The animals we would take with us on the trip would get released into their new home forever. And with time, they would evolve and adapt to their new environments. The law of the jungle could change a bit too. Lions might not be kings anymore. Deer are. Their antlers are twice the size of what they used to be. But to be fair, so are the deer. Most of the animals that were already here used to live underwater. But with time, the amphibians started shifting to the surface, just like Earth at the beginning of life. Pluto could only be a temporary home though. Once the Sun has finally reached its final phase, Pluto would get frozen and lifeless again. People instead would need to try to find a planet that stays in the Goldilocks zone of another galaxy. The Goldilocks zone is the exact proper distance from the star like the Sun, where the temperature is perfect for the water to stay liquid. It's the rule scientists search for when looking for other planets that can sustain life. We can try setting new colonies on one such planet, or even try to set up our own artificial home, not exactly a planet or a spaceship, but a combination of both. Something huge built right in space, say a wheel with gravity everywhere we go, so we don't fall off. It would float in space toward the new exoplanet, capable of fitting entire states in. This whole trip might happen just because the Sun first grew too much, And then, having reached the culmination of its life cycle, it would finally become a white dwarf. It's going to be a pretty long journey, and entire generations will be born here. You'll have a choice: sleep your way through the journey until humans finally reach their new exoplanet, or enjoy the trip in this fantastic spaceship. There's all you need on board: malls bigger than those on Earth, large futuristic cities, even places to farm, fields with rich soil made artificially, and finally, after a long journey, the exoplanet. It's even somewhat better than Earth. The planet is giant and has more continents. The continent's center isn't as far from oceans, which means there aren't as many desert areas. Though the sun of this planet is an orange dwarf, it's not as hot as our yellow dwarf sun today. It's a bit smaller, but here's the kick: orange dwarfs live somewhat longer. They remain stable for between 15 billion and 45 billion years. Despite that, this new planet is full of rainforests because the planet itself is warmer. It means more biodiversity and creatures we've never seen before. But even if nothing out there is suitable, we could try and terraform this planet instead. If we take Mars as an example, we could create a greenhouse effect by smashing ice-rich comets and releasing ammonia in them, making the planet warmer. We could also start planting trees. We'd probably need some Earth soil to do that, or we'd have to modify Mars's soil to be similar to ours. Sooner rather than later, the atmosphere would be close to the one we have on Earth. We'd be able to breathe, too, because of the trees. Then, we can melt Mars's polar ice caps and, voila, water. The problem is the solar winds and sun explosions that might strip it of an atmosphere just as quickly as we can create one, if not faster. It has no magnetosphere either, which means it can't protect us from radiation, so long-term Mars wouldn't be a good choice. Maybe out there, in the vastness that is space, there is a perfect planet waiting for us.
Pluto, an ex-planet and now the most famous dwarf planet in our solar system, is hiding somewhere far, far away in its dark corner. The temperature of Pluto's surface is freezing. I mean, wow! At first sight, it's just a distant, icy, and barren celestial body. But could Pluto be hiding something? Maybe even life? Scientists found out that, despite it being so far from the Sun, its interior is still warm. It's been that way ever since Pluto formed. Under the haze-layered atmosphere of Pluto, there's a frigid surface full of craters and impure water ice. There's also a large impact basin flooded by frozen nitrogen. And below that icy crust could be an internal ocean. When the surface of a planet stretches, it mostly leaves many fractures behind. The same goes with Pluto. You can see there are numerous cracks across its water-ice crust. They're of all ages. Some even possibly date from 4.5 billion years ago, from the times when Pluto was still forming. The dwarf planet probably grew because it slowly accumulated small pieces of icy material. It condensed during the time when the outer region of our solar system was forming. This process was going intensely and fast enough to melt the base of the icy layer. The surface of Pluto extended as liquid water at the top of the ocean froze onto the base of its ice crust during its first 500 million years. The ocean may have stopped freezing for the next billion years. The buildup of radioactive heat temporarily balanced the rate of heat escape to space. But as Pluto produced less radioactive heat over time, the roof of its interior ocean continued to freeze, and it probably turned into a 120 miles thick layer between the rock and ice. Crusts were the first hint there might be an ocean there. Scientists got the second potential piece of evidence when they realized the icy shell had managed to glide across an essentially frictionless interior and reorient itself. And it's not just about the ocean here. The cool thing is that wherever there's water, there could be life. A potential ocean under an icy crust is not something that possibly exists only on Pluto. Some icy moons of our solar system have it too, like Saturn's moons Enceladus and Titan, and Jupiter's Europa. Enceladus and Europa could both have salty liquid oceans. Plus, they have similar water plumes erupting from their interior. These geysers tell us these moons have their own source of energy, probably because of radiation or gravity. Either way, that energy is what could support life. Have you heard of Ceres, It's our closest dwarf planet, the biggest object in the asteroid belt between Jupiter and Mars, and the first asteroid we discovered at the beginning of the 19th century. People even called it a planet then. Although it's not so popular, there's a possibility Ceres has a subsurface ocean too. Geysers could be the first sign of that. The water vapor plume could be a result of a meteorite strike that exposed subsurface ice to outer space. Ceres may have its own atmosphere too. This dwarf planet is relatively far from the Sun, but its surface temperature could go up to minus 37 degrees Fahrenheit. At these temperatures, if there was water ice at its surface, it would quickly change to gas, and this could create an atmosphere around this intriguing dwarf planet. Not just oceans, there are many volcanoes across our solar system too. Mercury, Venus, Mars, and Io, one of Jupiter's moons, have them. But apart from the Earth, Io is the only one that has more than 400 active volcanoes. 150 of them erupt at any given time. Scientists suspect there could be some volcanic activity on Venus and Jupiter's moon Europa too. But they can't check if that's true because Venus has an extremely thick atmosphere and Europa has a thick ice shell. And even though volcanoes in other spots are no longer active, we know they used to be because of specific landforms they left behind – hills, valleys, plains, mountains, and especially lava channels. It's like when you're watering your plants on the front porch, you see water flowing down your sloped driveway along specific pathways. This creates small channels, a lot like lava does. Our moon may have also had active volcanoes back in the age when dinosaurs were still roaming around. If they had had telescopes, they might have seen something spectacular – lava fiercely oozing from the surface of the moon. Astronauts took images of Ina, an unusual volcanic deposit on the moon, and there are 70 similar patches in the volcanic plains they found on the side of the moon that faces our planet. Some of them are over 1 billion years old, but some could have been formed less than 100 million years ago, and dinosaurs went extinct 66 million years ago. Speaking of dinosaur extinction, could Jupiter have been the main culprit for that? No one knows where this space rock that hit our home planet 66 million years ago came from, especially with such force. It left a crater off the coast of the Yucatan Peninsula in Mexico, and it probably caused earthquakes, tsunamis, and fierce volcanic eruptions that brought troubles not only to dinosaurs, but to nearly 3/4 of all animal and plant life on Earth. But some believe Jupiter was the one that flung the comet into the Earth. Gravity is a tricky force that can make the solar system act like a big pinball machine. Jupiter is our most massive planet, which means it has extremely strong gravity. It's like a guardian of our solar system that kicks many incoming comets away, sometimes bringing them pretty close to the Sun. As they get there, these comets can experience extremely strong tidal forces that break them apart and, in the end, create long chunks of a comet. And one of these chunks probably went towards the Earth. Have you heard of the story of Triton? Neptune has 13 moons, and Triton is the largest of them. It's the only giant moon in our solar system that has a retrograde orbit. It means it circles its parent planet in the opposite direction of its rotation. Scientists believe that's because Triton used to be in the Kuiper Belt, a disc-shaped area located in the outer solar system, past Neptune's orbit. And it's possible that Neptune's gravitational force pulled it out of that region millions of years ago. Pluto may have originated within the Kuiper Belt too. Pluto and Triton are almost the same. They have similar density, mass, and surface material. Now Triton is locked away in synchronous rotation with its parent planet Neptune, far away from what we believe is its homeland. Now, the most distant object we've discovered so far in our solar system is a mysterious planetoid called, wait for it, Far, Far Out. 1 astronomical unit is the average distance between the Earth and the Sun, around 92 million miles. Well, Far, Far Out is 132 astronomical units from the Sun, 4 times farther away than Pluto. Since it's so far away, Far, Far Out needs about 1,000 years to finish a single circle around the Sun. Far out! Have you ever imagined what would happen if 2 gas giants collided? The chances are small, but if something like this happened, not much matter would be lost, although it depends on the angle and the speed of impact. A head-on collision would make them completely merge and not lose any matter at all, whether we're talking about their gaseous envelopes or their solid cores. But at high speed, their two cores would merge and both planets would lose most of their envelope gas. At very, very high speeds, bam, both are gone. If there was an oblique collision, two cores could completely avoid each other. Planets would merge, but a substantial fraction of their gases would vanish into space. And in a very oblique collision, kind of like a sideswipe, planets would keep going like nothing happened. There's no evidence for that, but one theory even says Jupiter and Saturn, or at least one of them, might have formed by merging from smaller gas planets. Yep, it's all about gas. A few years ago, NASA caught a mysterious green glow on Jupiter. It was moving at breakneck speed and almost escaped detection. Could it be proof that Jupiter has secrets we've been missing for decades? And if so, how will it affect us humans on Earth? Well, the truth is, astronomers didn't just stumble across this phenomenon. They've been studying Jupiter very carefully for a long time. The reason is the Juno mission. The Juno spacecraft was launched in 2011, and it reached Jupiter in 2016. Since then, it's been orbiting the planet and collecting tons of data. Juno's job is to help us understand what Jupiter is made of, how its atmosphere works, and what's happening deep inside the planet. In 2020, one of Juno's cameras, called JunoCam, clever, captured something strange. Near Jupiter's North Pole, a bright green flash of light occurred. This light appeared to be moving very fast. Capturing fast-moving objects in space is extremely difficult. That's why this image surprised many scientists. So, what could this green glow be? The most plausible and widely accepted explanation is lightning. But lightning on Jupiter is very different from lightning on Earth. On Jupiter, lightning forms inside massive clouds made of ammonia and water. These storms are far stronger than anything we experience here, and they can produce unusual colors, including green. But what if the green glow isn't lightning at all? Why didn't we see it before? This glow could always exist, but it probably moved too fast for our cameras to catch until now. Anyway, if we spot it again, we would be able to study it more closely and figure out what's really going on. Until then, a lot of the explanations are still educated guesses. Another question is what this might mean for Earth. Scientists are sure it won't have any direct impact on our planet. But the discovery is still important. It shows that weather-like phenomena such as lightning exists on other planets, and sometimes in much more extreme forms. Like on Mars, for example. Scientists have just discovered that the planet's atmosphere crackles with static electricity. In other words, Mars has tiny lightning. Back in 2021, when a dust devil rolled over NASA's Perseverance rover, scientists expected to hear the usual stuff: sand scraping, wind rushing past. Instead, the rover picked up a faint pop. At first, it didn't make much sense, and now, researchers finally think they know what it was. That sound likely came from electricity discharging in Mars's thin air. Basically, mini lightning on Mars. It doesn't look like lightning on Earth. There are no bright flashes streaking across the sky. Mars's atmosphere is too thin for that. Instead, these are tiny sparks. Still, they count as lightning, which officially makes Mars the third planet beyond Earth known to have lightning, after Jupiter and Saturn. How did scientists find this? Well, Perseverance has a microphone called SuperCam mounted on its mast. Over 2 years, it recorded about 28 hours of Martian sound, and hidden in all that audio were 55 short bursts that matched what you would expect from small electrical discharges. The sparks were super tiny, like those little shocks you get when you touch a doorknob after walking across a carpet. Yeah. Each spark lasted only milliseconds, but 7 of them also lined up with electromagnetic interference. This is a big clue that electricity had jumped through the air near the rover. But where does this Martian lightning come from? On Earth, lightning forms inside storm clouds when ice particles collide. Now Mars doesn't have rainstorms like that. It's too cold and dry, but it does have a lot of dust. When strong winds whip dust grains around, they rub into each other and trade electric charges. Scientists use a long and complicated word to describe this phenomenon, triboelectrification. But the idea is simple. Friction builds up electricity. Once that charge grows strong enough, it releases. That release creates both sound and electromagnetic waves, the very signals Perseverance detected. These tiny sparks might sound harmless, but they matter a lot. Electrical activity can change Mars's chemistry. It may help create reactive chemicals like hydrogen peroxide and percolates, which break down organic matter. That could help explain why Mars struggles to preserve signs of ancient life. Electricity might also affect how dust moves. Charged dust lifts more easily, which could help dust storms grow and support themselves. That creates something like a feedback loop. More dust, more charge, more storms. And there's a practical side too. These sparks won't hurt astronauts directly, but they could interfere with electronics or damage sensitive equipment. Knowing when and where they happen will help engineers design future missions and future spacesuits to handle Mars's electrically active environment. Now, let's move further away from the Sun. Here's something that might change how you picture the solar system. New simulations suggest that Uranus and Neptune might not be giant balls of ice after all. They could actually be much rockier on the inside, with thin icy layers around. Researchers at the University of Zurich ran new models and found that these ice giants don't have to be ice-dominated to match what we observe. In fact, many of their simulations work just as well if these planets contained a lot more rock than expected. Based on the data we have today, Uranus and Neptune could be rock-heavy or ice-heavy. There's just not enough information to choose between the two. That's why scientists keep calling for missions that would orbit these planets and study them up close. Voyager 2 flew past Uranus in 1986 and Neptune in 1989. It grabbed a few measurements and kept going. No spacecraft has ever stayed long enough to really figure out what's happening beneath the clouds. So scientists rely on computer models built from limited clues. The classic ice giant picture still works, but it's no longer the only explanation that fits the data. Now, another astonishing discovery involves Uranus's moon, Ariel. Even though it's small, scientists now think it could have once hidden a massive underground ocean that made up more than half of its entire volume. That ocean could have been around 105 miles thick, and it might have existed as recently as 1 billion years ago. Ariel is only about 720 miles wide, roughly a third the size of Earth's moon. Because of that, scientists used to assume it couldn't hold on to heat for very long. Newer research doesn't quite agree. When Voyager 2 flew past Uranus in 1986, it sent back images showing that Ariel's surface didn't look old and frozen. Instead, the moon looked relatively young and active, with cracks, ridges, and even signs of ice volcanoes. Some of those features look surprisingly similar to what we see on moons, like Europa, Enceladus, and Triton. And those are places we already know have oceans beneath the ice. Later on, scientists also found traces of ammonia and carbon-based compounds on Ariel's surface. Those chemicals usually don't last long, unless something keeps bringing them up from below, which often means liquid water underground. Researchers built models of what the inside of Ariel might look like. In their simulations, the moon had a brittle outer crust, a softer layer underneath, a deep ocean below that, and a solid core at the center. After that, they tested how Ariel's crust would react to tidal forces, the constant stretching and squeezing caused by Uranus and nearby moons. It turns out that if Ariel's crust was less than about 19 miles thick, it would crack under a serious amount of tidal stress. One source of that stress could be an interaction with another moon, Miranda, about 1 to 2 billion years ago. That interaction slightly stretched Ariel's orbit and put enough strain on the crust to break it. In any case, It's too early to claim that Ariel still has a huge ocean today. It's small and it loses heat easily. If any liquid water remains, it's probably much thinner and not exactly a great place to look for life. This star is in its T Tauri phase. It's surrounded by a giant donut-shaped disk of dust and gas circles. Most of the material in the disk falls back onto the star, but some dust particles crash into one another. If the collision is relatively gentle, they clump into much larger objects. At first, these objects are no larger than the width of a strand of human hair. With time, dust clumps turn into pebbles. Pebbles become large rocks. The gas helps these rocks stick together, and while some of the bigger objects break apart, most of them turn into the building blocks of future planets, planetesimals. While orbiting the star, the planetesimals clear all the material away from their path. All that is left behind is just some fine dust. Billions of years later, the disk surrounding the star completely transforms. It's now colder and farther away from the heat of its parent star. The water it contains can finally freeze, and tiny particles of ice are now traveling around the star along with the dust. With time, they form snowballs that later turn into giant planetary cores. And since these regions of space are colder, gas molecules there slow down and get drawn into this core. Astronomers believe that's how gas giants like Jupiter, Saturn, Uranus, or Neptune are formed. Interestingly, Jupiter and Saturn were the first planets to form in the solar system. It took them a mere 10 million years or so. Closer to the star, other planets begin to appear. Those are rocky planets like Mercury, Venus, Earth, and Mars. Such space bodies can take tens of millions of years to form after their star is born. After planets start orbiting their star, they are referred to as a planetary system. This system can consist of one or several planets and include natural satellites, asteroids, dwarf planets, meteoroids, and comets. The Sun and the 8 planets orbiting it are known as the Solar System. The closest planet to the Sun is Mercury. The place looks eerily similar to the Moon, Earth's natural satellite. But from up close, it becomes clear that it's just an illusion. Mercury is one of the 4 rocky planets of the Solar System. It has a solid surface. All over the place there are craters created by space rocks. Mercury is the smallest of all the 4 inner planets. It's just 3,000 miles at the equator. If you decided to see the entire Mercury, it would take you about 2.5 days to drive all the way around the planet. That is, if you were driving your car at a speed of 50 miles per hour without stopping. But driving there wouldn't be a simple task. The planet's surface is littered with gigantic hills with steep slopes. Some of them reach a height of 2 miles. Mercury doesn't have an atmosphere, and the temperatures on the planet are extreme. 800 degrees Fahrenheit during the day and minus 290 degrees at night. It's also the second densest planet in the solar system, topped only by Earth. Mercury has a massive metallic core. It takes up almost 85% of the planet's volume. The core alone contains more iron than any other planet of the solar system. Not so long ago, astronomers discovered that Mercury might have not only the outer core, which consists of liquid metal, but also a solid inner core. The planet's outer shell is composed of a rocky mantle and solid crust, which is just 300 to 400 miles thick. Instead of an atmosphere, Mercury has a thin exosphere. It's made up of mostly oxygen, sodium, hydrogen, helium, and potassium. But the planet is too close to the Sun. That's why the solar wind and striking meteoroids keep sweeping away the atoms of this exosphere. Now, Venus is very different from the bluish planet you might have seen in pictures. It's surrounded by a super-dense atmosphere made up of carbon dioxide. If you decided to land on the planet's surface, you'd have an opportunity to observe thick clouds of sulfuric acid pass by. By the way, if you need a drink on Venus, be sure to only drink H2O. If you drink H2O2, well, that'll be your last drink. The planet's surface is actually reddish-brown. Venus is a dry and hot place, with a pressure 90 times greater than that on Earth. Flat, smooth plains cover 2/3 of the planet's surface. But there are also large mountains. Those are volcanoes. Most of them are extinct, but some might still be active. Venus has two vast highland areas the size of South America and Australia, and several expansive lowlands. There are also long, winding canals. They're old lava flows, and some of them reach 3,000 miles in length. The planet's dense atmosphere creates a greenhouse effect, similar to that on Earth. It traps heat, and temperatures on Venus rise up to 880 degrees Fahrenheit. That's hot enough to melt lead. The pressure on the planet's surface is the same as at a depth of 3,000 feet underwater on Earth, crushing. The planet's metallic iron core is 2,400 miles wide. That's almost as much as the distance from New York to Los Angeles. The next layer is a molten rocky mantle that's 1,200 miles thick. Venus's insides are covered with a crust. It consists mostly of basalt and is 6 to 12 miles wide. The planet's thick atmosphere is nightmarish. It's 96% of carbon dioxide with 3% of nitrogen and thick clouds of sulfuric acid. Earth is the third planet from the Sun. From space, it looks like a blue marble with areas of green, yellow, brown, and white swirls. All that blue area is water. It covers 71% of our planet's surface. Even from up there, you'd spot the Great Barrier Reef near the shores of Australia. It stretches for 1,600 miles. That's more than the distance from Boston to Miami. From space, you could also see all the 277 miles of the Grand Canyon at once. Earth is the densest planet in the solar system. At its center, there's a core that takes up 15% of the planet's volume. The core consists of two parts, the outer and inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles. That's 20% of the entire Earth's radius, or 70% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also contains iron and nickel, but it's not under enough pressure to be solid. The temperature at the boundary of our planet's inner and outer core is 10,800 degrees Fahrenheit. That's as hot as the surface of the Sun. And the pressure there is 3.3 million times the atmospheric pressure at sea level. The mantle surrounds the outer core. This layer is about 1,800 miles thick and makes nearly 84% of the entire Earth's volume. It consists of silicate rocks rich in iron and magnesium. The crust is a relatively thin layer that takes up only 1% of the Earth's volume. Along with the upper part of the mantle, it's broken into tectonic plates. They move as fast as your fingernails grow and let heat escape from the Earth's interior. The crust is mostly made up of oxygen, silicon, aluminum, iron, and other minerals. The fourth planet from the Sun is Mars. It's the last of the inner planets. They're also called terrestrial, since they're made up of rocks and metals. This place is freezing cold. The temperatures here drop down to minus 80 degrees Fahrenheit. Even from afar, the planet looks reddish. It's mostly because the ground there is covered with rusty-colored dust. The same fine dust is floating in the air. Mars is full of colors: golden, brown, tan, and even greenish hues. They depend on the minerals that make up the soil. The size of the dust layer varies from area to area, but in most places it's 7 feet thick. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. The tallest planetary mountain in the solar system, Olympus Mons, is on Mars. It's 2.5 times higher than Mount Everest and about the size of Arizona if you stretched a tape measure across it. Martian atmosphere is much thinner than Earth's and contains 95% carbon dioxide and a mere 1% of oxygen. Dust storms sometimes cover the entire planet, and the largest ones can even be seen from Earth. Mars has a core that's made mostly of iron, nickel, and sulfur. It's between 900 and 1,200 miles wide. The core doesn't move. That's why Mars doesn't have a planet-wide magnetic field. The mantle surrounding the core is composed of thick silicates, oxygen, and some minerals. You can probably compare it with soft, rocky toothpaste. Mars's mantle is also much thinner than Earth's. It's just 800 to 1,100 miles thick. The thin planet's crust consists of volcanic basalt rock. Astronomers think it isn't broken into tectonic plates and remains in one piece. The crust is covered with fine reddish dust that looks like talcum powder. Moving on, Jupiter is the largest planet in the solar system. It's more than 89,000 miles wide at the equator. Jupiter is so huge it could fit 1,300 Earths inside it. It's also terrifyingly hot, about 43,000 degrees at the core. It's impossible to land on the planet. Jupiter is a gas giant with an atmosphere made up of hydrogen and helium gas. It's hidden away by a layer of thick brown, yellow, red, and white clouds. They make the planet look colorful and beautifully striped. One of the most unusual phenomena on Jupiter is the Great Red Spot. That's an enormous spinning storm the size of our home planet. It's been raging for the last 360 years. The hurricane's color varies from pale salmon and white to dark brick red. It's extremely windy on Jupiter, with wind speeds ranging from 200 to 400 miles per hour. Like I said, Jupiter is a gas giant. If the planet was 80 times as massive as it is now, it would have a chance to turn into a tiny red dwarf star. It's still unclear whether the planet's core is a molten ball of liquid or a solid rock 14 to 18 times the mass of Earth. There's even some evidence that the gas giant's core might be melting right at this moment. Whatever the truth is, the temperatures at the center of Jupiter reach 63,000 degrees. Around 90% of the planet's atmosphere is hydrogen. The remaining 10% is made up of helium with tiny traces of other gases. Under immense atmospheric pressure, hydrogen and helium gases turn into a dense fluid. Closer to the core, this liquid becomes a mixture of metallic hydrogen and helium. Since there's no solid ground on the planet, astronomers define the planet's surface as the point where the atmospheric pressure equals that on Earth. You wouldn't be able to stand on that surface, though. It's just another layer of gases. But the gravitational pull there is more than 2.5 times more powerful than on our planet. Now, like Jupiter, Saturn doesn't have any solid surface. This planet's made up of mostly hydrogen and helium. If you visited it, you would notice that the temperature and density on Saturn change the deeper you go. If you wanted to step on Saturn's surface, you just fall into the planet. Its gravity is similar to that on Earth, and the density at the surface is very low. That's why you'd free fall until the ever-increasing pressure crushed you. Now from above, it looks as if the gas giant does have a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. The visible outer layer is ammonia clouds. Under them, there are hydrosulfide clouds, and the innermost layer is made up of clouds of water. Saturn is an extremely windy place. Wind speeds here reach 1,100 miles per hour at the equator. For comparison, the fastest wind speeds on Earth don't exceed 250 miles per hour. Saturn is mostly composed of hydrogen and helium, with some traces of methane, ammonia, and water. But it contains more sulfur than Jupiter, which gives the planet a smog-like orange hue. The atmosphere of Saturn isn't really different from its surface, but the deeper you go, the higher the pressure is. At some point, it makes hydrogen turn into a liquid. Further to the center of the planet, this liquefied gas turns into metallic hydrogen. Like Jupiter, Saturn might have a rocky core with hydrogen and helium surrounding it. On the other hand, even if it's made up of rocky material, the core can still be liquid. One of the most recognizable features of Saturn is its awesome gray, beige, and tan rings. These groups of tiny ringlets are made of chunks of rock and ice. Saturn also has 53 confirmed and named moons. Another 29 moons are still waiting confirmation of discovery and official names. Titan, an icy world bigger than our moon and even Mercury, is the largest of Saturn's moons. Saturn is the least dense planet in the solar system. It has 1/8 the average Earth's density. If you found a pool of water huge enough to fit the ringed planet, it would float on the surface. And still, because of its large volume, the planet is 95 times more massive than Earth. Out further, a blue-green ball of ice and gas 1.7 billion miles away from the Sun is Uranus. This ice giant has such a beautiful hue thanks to the light from the Sun. It gets reflected off the planet's surface. The planet isn't solid. If a small asteroid collided with Uranus, it would simply fly through the upper atmosphere and sink into the icy liquid center. Now, Uranus orbits the Sun on its side. It's the only planet with its axis pointing almost directly at our star. It might be because of a collision with a large space body soon after the formation of the planet. In summer, extreme storms shake the planet. Such hurricanes only occur when Uranus is heated to its most. A hurricane can sometimes spread for over 6,000 miles. That's almost the distance between Japan and the US. The planet has two sets of rings. The inner system consists of 9 narrow dark rings, and the outer rings are bright, one blue and one red. At the very center of Uranus, there's a rocky core. It's small, just half of Earth's mass. Compared to other planets, Uranus's core is rather cool, a mere 9,000 degrees. An ice mantle surrounds the solid core. It takes about 80% of the planet's volume. It's not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia ice, and methane. Sometimes it gets referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium. The planet looks blue-green because of methane gas that absorbs the red light. Now, the farthest planet from the Sun, Neptune, is only 4 times the size of Earth, but 17 times as heavy. The blue surface you see in pictures is actually a layer of swirling gas and permanent clouds. The planet's mantle, which is made up of water, ammonia, and methane ices, is the closest thing Neptune has to a surface. And still, this surface isn't solid. If you made a decision to get down to the very core of the planet, you'd feel great temperature changes. It would vary from minus 340 degrees at the surface to more than 12,000 degrees at the core. Such mind-boggling temperature differences create powerful storms whose speeds reach 1,200 miles per hour. No wonder Neptune is considered the windiest planet in the solar system. Like Uranus, Neptune is an ice giant. The planet's core is solid and consists mostly of iron and some other metals. Its mass is 1.2 times greater than that of Earth. Astronomers also believe that at a depth of 6,200 miles, there might be a layer where it rains diamond crystals. The planet's core is surrounded by a large mantle. It's a superheated region of liquid with temperatures as high as 3,000 to 8,500 degrees Fahrenheit. The mantle is rich in methane, ammonia, and water, and equals up to 15 of Earth's masses. Neptune's atmosphere forms 5 to 10% of the planet's mass. It stretches 20% of the way down to Neptune's core. The atmosphere consists of 80% hydrogen, 19% helium, and a bit of methane gas. The methane gas is what gives the planet its bluish hue. But what do planets look like outside our solar system? Are they the same as our rocky worlds and gas giants? Well, some of them are pretty bizarre. We're now 40 light-years away from Earth, near an exoplanet called GJ 1214b. By the way, an exoplanet is any planet outside the solar system. It's about 3 times the size of our planet, but its mass is 8 times that of Earth. Once every 38 Earth hours, GJ 1214b orbits a red dwarf star. The temperatures on the surface of the planet are literally toasty, around 400 degrees Fahrenheit. But that's not the only thing that makes this planet so unusual. After observing this distant world through the Hubble Space Telescope, astronomers have calculated that GJ 1214b is a giant water world. It's encapsulated by a steamy and dense atmosphere. There's no other planet like that known to people. Because of the high pressure and high temperatures on the surface of the planet, such exotic materials as superfluid water and hot ice might have formed there. Meanwhile, this bright blue exoplanet is located 62 light-years away from Earth. It looks peaceful and slightly familiar. It's a bit larger than Jupiter, and its bluish color might remind you of our home planet. But this pretty appearance hides the planet's terrifying nature. Its beautiful hue comes from silicate atoms and particles that make up the planet's atmosphere. At the same time, the wind speeds there can reach a terrifying 5,400 miles per hour. That's 7 times the speed of sound. Temperatures on the planet are also extreme, over 1,600 degrees. But even this is not the worst. It rains glass sideways in this scorching hot world. If such a storm happened at the equator on Earth, it would only need around 5 hours to travel around the planet and destroy everything in its path. Several years ago, astronomers discovered a planet as large as Neptune, and it orbits a star that's no bigger than Earth. That's a truly strange setup since usually stars are way bigger than the planets traveling around them. What might explain this phenomenon is that the star we're talking about is not so much of a star anymore. It's a teeny white dwarf with a very tricky name. This dwarf is more of a stellar skeleton. It can't fuse elements within its core, which could prevent it from gravitational collapse. These days, it's a highly compressed, smoldering space body with an insane temperature of 49,500 degrees. In other words, the star is so hot that it's slowly vaporizing the nearby planet. Because of this insane heat, the planet is losing its atmosphere. The white-hot star is sending streams of vaporized material far away from the planet at a rate of about 260 million tons a day. Far-away Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. It's located 30 light-years away from Earth in the constellation of Leo. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means it's traveling remarkably close to its parent star. The distance between them is 15 times smaller than the distance between Mercury and the Sun. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X, and it remains solid despite blistering temperatures. One of the most plausible explanations for this phenomenon is the incredibly strong gravity on the planet. It compresses the trace amounts of water vapor in the atmosphere into ice and then stops it from melting. Now, about 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is 5 times the size of Earth. It needs only 2 hours and 10 minutes to orbit its parent star, which is a pulsar rotating 10,000 times in a minute. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline, meaning that at least some part of the planet is diamond. Now, look at this hot Jupiter. That's the name used to describe planets orbiting their home stars uncomfortably close. On WASP 76b, it rains iron at night. As for the daytime side of this planet, the temperatures there rise up to 4,300 degrees. That's hot enough to vaporize metal. The bizarre planet is just a bit smaller than Jupiter. It's located 640 light-years away from our home planet. The terrifying weather conditions in this world are caused by its extreme orbit. WASP 76b is 10 times closer to its parent star than Mercury is to the Sun. It makes this star and the huge planet tidally locked. One of the sides of WASP 76b is always baking in the heat coming from the star, and eternal night reigns on the other side. Now, a mere 20 light-years away from the Sun, a bizarre rogue planet is roaming the Milky Way. This planet doesn't have a star of its own, but this nomadic world has an insanely powerful magnetic field. According to a 2018 study, it's 4 million times stronger than Earth's magnetic field. The exponent, with a long and complicated name, also produces amazing auroras. When SIMP was first discovered in 2016, astronomers thought they had spotted a brown dwarf. That's an object that's too large to be a planet and too small to be a star. But another study proved that the thing was small enough to be considered a planet. Of course, this planet is a mammoth among its peers. It's 1.2 times the radius of the largest planet of the solar system, Jupiter, and more than 12 times its mass. Astronomers say that the exceptionally powerful magnetic field helps the planet produce such stunning auroras, but they are generated in a different way than auroras on Earth. The scientists claim SIMP's moon might help the planet create its light shows. This planet is nothing like you've seen before. It's often referred to as a super Saturn or Saturn on steroids, all because J1407b has a huge system of rings. They're 640 times larger than those on Saturn. This exoplanet sits 434 light-years away from Earth. It's the only known world with rings similar to those on Saturn. If J1407b ever swapped places with Saturn, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. Gliese 581c is located 20 light-years away from Earth in the constellation of Libra. It orbits its home star at a distance that is a mere 7% of the 93 million miles that separate Earth from the Sun. Gliese 581c is tidally locked with its star. It means that one of its sides always faces the star and the other is plunged into endless darkness. Of the sunny side, the temperatures are insanely high, and the dark side is freezing. But between these two extreme areas, there's a narrow zone with the conditions that could potentially support life. And how about visiting a planet where it might rain sapphires and rubies? Hat P7b is a pretty far away place. The planet sits more than 1,000 light-years away from Earth. On its night side, the atmosphere contains a lot of aluminum oxide, also called corundum, and corundum gems are sapphires and rubies. Astronomers think there might be powerful storms on the planet when it literally rains rubies and sapphires. That's why these gems might be scattered all over the planet. There's also a planet that eats up light. It's called WASP 12b. It's one of the darkest exoplanets we know about. That's because its day side consumes light rather than reflects it back into space. The planet is enormous, twice the size of Jupiter, and it traps more than 94% of the light falling into its atmosphere. This might be the reason for the insane temperatures there, 4,600 degrees Fahrenheit. WASP 12b travels so close to its parent star that it completes one orbit within a day. Its night side is twice as cool as the day side, a mere 2,200 degrees. But thanks to this difference in temperature, water vapor and clouds form above the surface of the planet, and then swirls of material from WASP 12b's superheated atmosphere spill onto its star. Now, see that jaw-dropping magenta-colored exoplanet? It's located in the constellation of Virgo. It's called Gliese 504b. The distance between this planet and its home star is 9 times the distance between the Sun and Jupiter. The planet is relatively newly formed. It's still glowing with heat. That's what makes its surface look pink. We've traveled 20,000 light-years and reached a red dwarf in the Sagittarius constellation. Far away from this cold star, there is a planet with another long and tricky name I'm not going to attempt. This world is so far away from its parent star that it receives very little heat. It's one of the coldest planets we know about. Its surface temperature is lower than minus 360 degrees. That's why the entire planet is encased in a thick layer of ice. If you stepped on its surface, you'd see nothing but glaciers, vast plains, canyons, and mountains of ice. And still, astronomers think life could exist deep beneath the chillingly cold frozen surface. The planet's core might generate enough heat to melt some of the inner ice. If it's true, then there can be an enormous subsurface ocean on the planet.
Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating, and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. Low-mass stars sometimes flare up with radio energy, but not here, since they mostly have X-ray counterparts. Very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know as the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima b is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima b at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima b has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course, outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface, so this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light-years from our planet. This means we can see around 28 billion light-years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere, which is like some sort of a warming blanket that helps maintain the heat coming from the Sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out, it just keeps it, and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. But it's less transparent to lose long wavelength radiations that the warm, heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. In maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, Temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there'll be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our sun way farther than Pluto, such as Kuiper Belt objects and trans-Neptunian objects. There's also an Oort comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy. Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune. The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles.
Colonizing other planets is like the ultimate cosmic adventure. It's a challenge that has captured the imagination of humans for centuries, and it's something that we've always dreamed of doing. One of the most popular candidates for this role is Mars. And this isn't surprising. Mars is a rocky planet that is similar to Earth in many ways, and it even has evidence of water on its surface. This makes it a prime candidate for human colonization. Many scientists and engineers are working on plans to send humans to Mars and establish a permanent settlement there. But what about the other candidates? There are many planets and moons in our solar system, so why not colonize something else? For example, Ceres? Ceres is the ultimate cosmic treasure trove. It's a dwarf planet, not a full-fledged one, just like Pluto. It's located in the asteroid belt between Mars and Jupiter. This dwarf planet is the closest to the Sun, and it's adorably tiny. The entire planet is about the same size as the state of Texas. So why choose it? Because Ceres may be a rich source of valuable resources. The surface of Ceres is covered in craters and other geological features, and scientists believe that beneath its surface, it has a thick layer of water ice, which means that deep underground it may have an ocean of liquid water. If this is true, Ceres could be a valuable resource for future space missions. It could potentially provide a source of water for human exploration of the solar system. So, can we colonize it? And if so, how do we do that? Actually, many scientists and space enthusiasts have proposed this idea. To colonize Ceres, we'd have to use the same methods used to establish colonies on the Moon, Mercury, and the satellites of Jupiter and Saturn. Don't worry, it's not that hard. We just need to figure out how to adapt to a very thin atmosphere, to extreme temperatures and pressure and all the other nasty stuff. But let's stay hopeful. At the end of the day, it all comes down to resources. We'll need water, minerals, silica, and other raw materials. All this would help us to create a self-sufficient colony. And luckily, Ceres is full of these things. So first of all, we could locate the places of residence inside the craters of Ceres. We could build domes there that would protect us from all sorts of dangerous things, like radiation. We could also mine regolith in the asteroid belt. Regolith is a residual soil that appears as a result of cosmic weathering of the rock. Basically, it's something like the surface layer of soil on the Moon. Why do we need it? Well, because we could use it to 3D print the base layers next to the ice, so that our bases would be located near the water. We could then use these base layers to print other structures, like houses. We could also collect ice and organic molecules to create water, and by combining water with regolith, we would get soil in which we could grow plants and food. Wonderful. There's also another option. A colony can be created underground, that is, right next to the icy crust of the planet. Now, if in the future we'll be some kind of super cool scientists, we could try to accelerate the rotation of Ceres, which sounds crazy, but would be pretty beneficial. It would help us to create artificial gravity inside the underground colonies. And speaking of gravity, all of these things may sound cool, but let's discuss the difficulties that lie ahead of us during colonization. To colonize Ceres, we would need to overcome a number of challenges. To begin with, we need to develop technologies that will help us even get to Ceres. We need some kind of ships that would be capable of long flights into deep space. For them, first we need to create some kind of nuclear thermal or nuclear electric traction, and maybe an even more advanced type of fuel. Then we'll also need technology to help us sustain life in this small, rocky world. That is, tools to extract and use local resources. Also, since there is no atmosphere on Ceres, we would have to wear spacesuits and live in pressurized habitats. And this is only the beginning. Living on the planet itself won't be an easy task either. For example, what about extreme temperatures, or radiation, or the mentioned incredibly weak gravity? The latter is definitely one of the biggest problems. The gravity of Ceres is only 3% of the Earth's. You wouldn't want to accidentally fly into outer space while playing football, would you? But the fact that any jump could send you on an endless journey isn't the only problem. Even if you somehow stay on the surface of the planet, you'll experience the same symptoms and problems as astronauts who hang out on the International Space Station. For example, loss of muscle mass, decrease in bone density, deterioration of vision, problems with the cardiovascular system. Wow, who would have thought that gravity is so important? So therefore, if we wanted to survive on Ceres, we would need either a bunch of doctors or some kind of artificial gravity. And don't even get me started on how low gravity will slow down production and work. And of course, we can't go anywhere without discussing money. Colonizing Ceres will cost us a huge expense, especially taking into account all of the above. And yet, despite all these things, Ceres still stays one of the best candidates for colonization. For example, Ceres contains lots of methane and ammonia. They can be used as a manufactured fuel or a nitrogenous gas, or you can just mine it there in order to colonize Mars and Venus. Even low gravity has its advantages. Thanks to it, it will be very easy to launch spacecraft from Ceres. We'll waste much less fuel, which means that transportation from Ceres to other planets would be much cheaper and more efficient. So even if Ceres doesn't become our permanent residence, it can become a good transport hub, something like a spaceport. We could use it as a base for mining all sorts of useful things from the asteroid belt. Then, we could transport all these resources back to Mars or Earth, and it can also become a refueling station for ships traveling further beyond the solar system. Sounds cool and pretty sci-fi-ish, doesn't it? But it seems that any attempts to create a permanent base in the asteroid belt will have to wait. Colonizing other planets is a difficult and complex task. It will require the cooperation and expertise of many different people, and it will involve developing new technologies and overcoming many challenges. Before we go to Ceres, we need to build infrastructures on the Moon, Mars, and somewhere in between. Otherwise, any attempts to colonize it would be prohibitively expensive and would most likely fail before future missions could even reach it. But the more colonies we create, the more likely it is that sooner or later we'll build another one on Ceres. This would not only open the asteroid belt to economic exploitation, it would also serve as a stepping stone to the outer solar system. This, in turn, could lead to colonizing the moons of Jupiter and beyond. In other words, the rewards of colonizing Ceres could be great. Not only would it allow us to explore and understand this fascinating world, but it could also provide us with valuable resources that could help us to further explore and settle the solar system. Life on Ceres would likely be challenging, but exciting, as humans would be making a new home for themselves and exploring the mysteries of the universe. Just imagine all the new planet-themed restaurants and shops we could have. Welcome to Ceres Mart, where everything is out of this world. So if you're a fan of cosmic treasure hunts, Ceres is surely a rich and rewarding destination. Just make sure you bring some weights on your feet so you don't fly anywhere. It's dark and incredibly cold. There's no oxygen, there's no water, there's no life. But the James Webb Space Telescope doesn't seem bothered by all this. Its main goal is to find the very first galaxies that formed billions of years ago in the early universe and observe the stars making up distant planetary systems. Its mission is to... But wait, what is that? The James Webb Space Telescope has discovered something absolutely amazing, a star-planet hybrid with very strange clouds. This bizarre world, called VHS 1256b, is actually a brown dwarf. Those are bigger than planets, but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf we're talking about is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars. And to complete one orbit, the brown dwarf needs 17,000 years. In fact, astronomers found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Scientists have been putting forward theories about the existence of such sand clouds on exoplanets for quite some time. But the discovery the James Webb Space Telescope made is the first real proof. The silicate particles on the sandy dwarf are most likely quartz or some other mineral. In size, they're less than a micron, and 1 micron is 1/25 of a thousandth of an inch. In other words, they look like particles in smog. The exoplanet seems to have an atmosphere which contains some water, methane, and other substances and minerals. Interestingly, this atmosphere isn't still. It's constantly undergoing extreme changes. Another cool thing about it, scientists have detected carbon dioxide. And this is only the second confirmed discovery of this gas on a planet outside of the solar system. By the way, the James Webb Space Telescope, with the help of which astronomers discovered our sandy brown dwarf, is an absolutely stunning piece of equipment, around 100 times more powerful than Hubble. Even though the telescope itself is 3 stories high and its size equals that of a tennis court, its mirrors are the lightest large telescope mirrors of all time. When all the 18 mirrors of the telescope were completed during the manufacturing process, their mass was reduced by 92% in comparison to the initial discs. Each mirror weighed a mere 44 Aliyah-bas. The telescope's mirrors seem to be gold, but in reality, they're made of beryllium, steel gray, lightweight, and brittle metal. There's indeed a gold coating on each mirror. But they can't be produced entirely out of gold, since this material tends to expand and contract even with small temperature changes. That's why the total amount of gold in the James Webb Space Telescope is less than 2 ounces. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than 370 F. That's cool enough to make nitrogen liquid. A truly enormous 5-layered sun shield stretches around the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. The telescope orbits the sun more than 1 million miles away from Earth, and when it runs out of fuel, it'll keep orbiting the sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its life. Anyway, if you think that our newly found brown dwarf is the only bizarre exoplanet out there, let me show you some other breathtaking worlds. There is an exoplanet that is really something else. Just look at its awesome magenta color. You can find it in the Virgo constellation. The planet is called Gliese 504b. It orbits very far from its parent star, 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. One of the oldest exoplanets we know about, PSR BC 20-26b, is about 12.7 billion years old. It's almost 3 times as old as Earth. This also means that the so-called Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar making almost 100 revolutions per second. I bet sunrises on this planet must look awesome. Just 20 light years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming the Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's. The exoplanet also produces amazing auroras. That's why when it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf. But later, scientists got some proof that this space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet in the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create mesmerizing light shows. The next exoplanet isn't like any other. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those our Saturn has. This bizarre world is the only planet we know about that has rings similar to Saturn's. If you moved this giant to our solar system and used it to replace Saturn, its rings would look many times larger than a full moon. An exoplanet called WASP-12b munches on the light coming from its star. It's one of the darkest worlds people know about, all because its day side consumes light rather than reflects it back into space. The egg-shaped planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. It might be the main reason for the temperatures on the surface of the planet that can rise up to 4,600 staff. The night side of the planet isn't as hot as its day side, a mere 2,200 giraffe. The difference in temperature makes water vapor and clouds gather above the surface of the planet, and from time to time, swirls of material from the planet's superheated atmosphere spill onto its star. What a view! Discovered in 2017, Kelt 9b is one of the hottest exoplanets we know of. The temperatures there can reach 7,800 AOS. For comparison, the temperatures at the surface of the Sun reach 10,000. The planet is probably so insanely hot because it orbits extremely close to its star, Kelt 9, which is way hotter and bigger than our Sun. Experts believe that the giant star might one day evaporate the entire planet.
Ooh, that quick flash. Did you see it? That's an object smashing into the moon at unbelievable speed. And what makes it so special is that we almost never catch lunar impacts in real time. We still don't know what exactly hit it, but scientists think it might be linked to the Phaethon asteroid, one of the strangest, most mysterious objects we know of. This impact happened on December 12, 2025. Andrew Marshall Lee, a final-year PhD student, was doing a late shift at the Armagh Observatory and Planetarium in Northern Ireland. He was working with the Armagh Robotic Telescope, the newest and most advanced one there. Everything seemed normal at first. The moon was just sitting quietly on his screen. But then, around 3 in the morning, something unexpected happened. He saw a flash. That was the impact of a small object hitting the moon. The team is still trying to pin down its exact size, but they think it was no bigger than 2 inches across, which is about the size of a golf ball. And this object was moving insanely fast, at about 22 miles per second. To give you an idea, it's more than 100 times faster than a commercial jet. And yeah, I get it. When you watch the video, it's only a quick blink. It's not exactly thrilling. But the fact that Marshall Lee caught the exact moment it happened is actually super rare, and that's what makes this one such a big deal. It's the first video recording of a lunar impact flash in Ireland, and only the second one ever recorded from the United Kingdom. But just because it's rare to see that kind of event happen, that doesn't mean impacts on the moon are rare. It's actually the total opposite. We have a huge advantage on Earth, our atmosphere. It works like an invisible shield. It slows down incoming space debris, and it can even burn a lot of it up before it reaches the ground. But the moon doesn't have that kind of protection. So our poor natural satellite gets hit all the time by asteroids and meteorites. The good news is, most of what hits it is tiny, no bigger than little specks of dust. Now, if we talk about slightly bigger ones, we can look at some rough numbers. Scientists think around 100 space rocks the size of ping pong balls hit the moon every single day. That adds up to roughly 36,000 in a year. So, it's kind of strange that we don't capture these impacts more often. But the explanation is actually pretty simple. As we mentioned earlier, these space rocks are usually tiny, and if a ping pong ball already looks small here on Earth, imagine something that size flying through the huge emptiness of space. We can say it's basically invisible. That's why we usually can't spot them with a telescope. They're too faint for that. But the moment one of these little objects hits the moon at a crazy high speed, everything changes. The energy from the impact turns into heat and light. It blasts and melts a bit of the surface, and for a split second, it makes a bright flash that we can see from Earth. And there's one more problem. The moon is huge. Impacts can happen anywhere on its surface, so it's almost impossible to keep a telescope pointed at the exact spot where the next big hit will happen. So, most of the time, scientists don't catch lunar impacts with their own eyes. What usually happens is that they record the moon for hours, run all that footage through some software, and the program flags it if a flash shows up. But in Marshall Lee's case, he just happened to be looking at the screen at exactly the right moment, and he saw it happen live. Now you get how lucky he was, right? For now, the team has a pretty good idea of the space rock's size and speed, but it's still hard to say exactly what it was or where it came from. Their best guess is that it was linked to the Geminid meteor shower, which happens in December. And that actually makes sense. Lunar impacts are more likely to be spotted during big meteor showers, when the moon passes through streams of leftover space debris. So this could be one of those moments where the timing was just perfect. Now, the Geminid meteor shower is tied to one of the strangest space objects we know of, called Phaethon. It's labeled an asteroid, but it certainly doesn't behave like a normal one. You see, when Phaethon gets close to the Sun, it brightens up and even forms a tail, just like a comet. But its tail isn't made of dusty material the way comet tails usually are. According to NASA, its tail is made of sodium gas. That's why scientists are not totally sure what to call it. So, for now, Phaethon is officially listed as an asteroid, but a very weird one. Anyway, this strange object swings closer to the Sun every December, and when the heat gets intense, Phaethon starts shedding tiny bits of rock. When those little pieces dive into Earth's atmosphere, they burn up and make bright streaks across the night sky. At the peak of the Geminid shower, people can spot up to 120 meteors an hour under perfect conditions. The Geminids are usually bright and fast, and they often look a bit yellow. Of course, not all of those pieces hit Earth. Some miss us completely, and a few end up hitting the moon instead. And that's probably what Marshall Lee saw that night. Now, even though the impact wasn't huge, flashes like this are still really useful for science. Astronomers use them to estimate how often the moon gets hit by small space rocks. And once they know that, they can make better guesses about how many bigger asteroids are out there, the kind that could make it through Earth's atmosphere and cause real damage. And sightings like this matter for the future too, especially for space travel. Space agencies want to build bases on the moon, and the goal is to make it a place where people can stay and work, not just visit. The moon is our closest neighbor in space, so it's a great place to learn new things and try out new tools. It's also the perfect practice ground for bigger missions later on, like sending humans to Mars. NASA, for example, is working on something called Artemis Base Camp. The plan is a small base near the moon's south pole, with places for astronauts to live and work, plus a rover that can travel farther from where they land. NASA also has plans for the Lunar Gateway, a small space station that would orbit the moon and help crews and supplies move between Earth and the Moon's surface. There's also the International Lunar Research Station program. Its goal is to build a long-term research base on the Moon, starting with robotic missions that land first and prepare the area before people arrive. The program focuses on using local resources, such as ice in the Moon's soil, to produce water, oxygen, and other supplies needed for life. By staying on the Moon for longer periods, scientists hope to learn how humans can live and work far from Earth and use this experience to prepare for future missions to Mars and beyond. So, keeping an eye on these impacts and learning more about them could actually help us build a safer future beyond Earth. The more we understand how often these hits happen and how strong they are, the better we can plan and protect future lunar bases. In a way, that tiny flash on the Moon isn't just a cool moment on a screen. It's a small warning and a useful lesson for what comes next. So, astronomers have just announced that they might have found signs of possible life on a planet outside our solar system. Wow! This distant world is called K2-18b, and it sits about 124 light-years away in the Leo constellation. So, what life are we talking about? Little green men? Octopus-like tentacled creatures? Well, not exactly. First things first, let's define what life is. It's what distinguishes animals and plants from inorganic matter, like the ability to grow, reproduce, and change. Now, what do we need to support life? If what comes to your mind is water, bingo! Scientists have the feeling that K2-18b might be covered in oceans, and if it's so, it can support tiny forms of life like microbes. A team of researchers from the UK and the US used the James Webb Space Telescope to look at the planet's atmosphere. They found hints of two very special chemicals. On Earth, only living things can produce those, and the living things I'm talking about are mostly tiny ocean plants called phytoplankton. So, basically, this planet might indeed host life in the form of algae. Now, of course, scientists still need more proof before getting too excited. We should keep in mind that it's possible that those chemicals were made by something we don't understand yet, not necessarily by living things. But still. K2-18b is a big boy. It's more than 8 times heavier than Earth and about 2.5 times larger. So what makes it even more interesting is that it's located in the Goldilocks zone around its star. That means it's not too hot and not too cold there, just right for the existence of liquid water, which is highly important for life as we know it. Astronomers study faraway planets like this by watching how their light changes when they pass in front of their star. This allows us to figure out what kinds of gases are in the planet's atmosphere. Back in 2013, the James Webb Space Telescope found methane and carbon dioxide in the atmosphere of the planet. These are carbon-based molecules, and it was the first time they were found on a planet in the habitable zone. Scientists also saw a weak signal of a chemical called DMS, which is mostly made by tiny ocean life here on Earth. So, the researchers pointed the telescope at the planet again a year later using a different tool that could pick up more light details. This time, they found much stronger signs of DMS and some related chemicals. But the problem is the signals aren't strong enough yet. They haven't reached something called the 5 sigma level, a parameter scientists use to confirm discoveries. Plus, even if the DMS really is there, it doesn't automatically equal the existence of life. Scientists once found DMS on a comet, which means that it can be produced without some kind of life taking part in the process. And still, the amount of DMS on K2-18b looks way higher than anything seen on Earth. That's why some astronomers are sure it's coming from something living. K2-18b has been a top pick for what scientists call a Haitian planet. This term means a big, watery world with thick hydrogen atmosphere. It's not the kind of place where extraterrestrial civilizations like in movies would live. But it could be home to tiny life forms, like the microbes that once lived in Earth's oceans billions of years ago. Once again, not everyone agrees on how friendly K2-18b really is for life. Some scientists think planets like this might actually be too close to their stars to hold on to liquid water. K2-18b orbits its star every 33 days, which is pretty fast, and could mean it's too hot. That's why some experts claim that even if the planet has any water at all, it might be boiling. Or maybe it's not water, but oceans of lava. But most scientists agree on one thing: we should wait and see. With just 16 to 24 more hours of telescope time, astronomers could confirm what they've seen. This could happen in the next few years. And even if it turns out K2-18b isn't the world we're looking for, we're still getting close. With powerful telescopes like James Webb and more coming in the future, we might be able to answer whether we're alone in the universe or not. At the same time, some places in our own solar system, like Mars, Venus, or Saturn's moon Enceladus, might actually have a better shot at hosting life. Or we could keep exploring other promising worlds, like Proxima Centauri b, which is the closest exoplanet we know about. It's just 4.25 light-years away from us and orbits a small star called Proxima Centauri, right in the habitable zone. This planet is a bit bigger than Earth, which makes it a super-Earth. That's what we call exoplanets larger than ours, but much smaller than gas giants like Neptune or Jupiter. Proxima Centauri b is a fast-moving world. It needs a mere 11 days to go all the way around its star. Scientists think Proxima Centauri b might have a rocky surface, and that's a good sign for possible life. On the other hand, its star blasts it with a lot of ultraviolet radiation. It might have already destroyed the planet's atmosphere, if there was any to begin with. So there's a big question mark when it comes to this world's habitability. Then we've got TRAPPIST-1e, another promising Earth-like planet. It's one of 7 rocky planets orbiting a small cool star called TRAPPIST-1, about 39 light-years away. Discovered in 2017, it might be one of the most promising places to look for life beyond Earth. This planet is actually a bit smaller than Earth, with a mass around 1/2 that of our planet. It completes an orbit around its star in just 6 days, which is super fast compared to Earth's 365 days. The planet's size and density suggests it has a rocky surface, and that's another key factor when we talk about habitability. Even though TRAPPIST-1e is very close to its star, the star is quite dim and cool, so the planet might still have a stable Earth-like climate. Some scientists even think it could have more water than Earth. Let's move on to Kepler-186f, located about 500 light-years away. It was the first Earth-sized planet found in a habitable zone of another star. It orbits a red dwarf, which burns cooler and lives much longer than our Sun. This means Kepler-186f could have stable conditions for billions of years, giving life plenty of time to possibly form and evolve. The planet gets only about 1/3 of the sunlight Earth receives, so it would likely be cooler but still warm enough to keep water from freezing. It also seems to be a rocky planet just like Earth, which boosts its chance of hosting life. Now, how about visiting LHS 1140b, about 40 light-years away? This planet has about 5.5 times the mass of Earth. Scientists think it's rocky and possibly has a thick atmosphere, which is a big deal. An atmosphere like that can trap heat, keep temperature stable, and protect water from escaping into space. This world orbits a quiet red dwarf star, so it's not constantly blasted by harmful flares like some other exoplanets are. Some studies even suggest LHS 1140b could be an ocean world with lots of water. So it's one of the more exciting planets we've found in our neighborhood. And finally, we have Gliese 12b. Astronomers call it Exo-Venus. It sits 40 light-years away from Earth. This world is about the size of Venus and orbits a cool red dwarf star. It needs just under 13 days to complete one orbit. The temperature on the planet is around 107 degrees, which is quite warm but still okay for life. The thing that makes Gliese 12b so interesting is that it could help us understand how Earth-sized planets around cool stars hold on to their atmospheres. That's important because an atmosphere is crucial for things like liquid water and protecting life from harmful radiation. According to some researchers, Gliese 12b is one of the best chances we have to figure out whether planets like this can stay habitable. Well, NASA has just dropped the craziest news ever. They've found the clearest evidence yet that life might have once existed on Mars. So, is that what you'd see if you travel there? Well, let's imagine, shall we? The world around you is red, darker than Earth. There's a dust storm on the horizon. Suddenly, you spot a bizarre creature that makes your blood run cold. It's way taller than you, with long, creepy-looking arms and legs. Its skin is orange, and its eyes are huge. They look like some kind of shiny lenses. Come to think of it, it all makes sense. Gravity on Mars is 38% weaker than on our planet. That's why this creature has grown to be so tall. You know, when astronauts go to space, they tend to grow up to 2 inches, all because the reduced gravity makes the fluid between their vertebrae expand. As for the creature's unusually colored skin, this is protection against solar radiation. Mars doesn't have a global magnetic field. There's nothing to protect the planet from radiation. And the locals' bodies probably had to switch their pigmentation from melanin to carotenoids, the same pigments that give oranges, carrots, and tomatoes their bright color. As for those big, beautiful eyes, they help the creature perceive the light of our now-distant sun much better than regular human eyes. Now, if this is the story you wanted to hear, I'm sorry to disappoint you, because the life forms we've discovered on Mars are very different. And still, for scientists, they are no less exciting. Last year, the Perseverance rover, the most expensive off-roading robot ever, found a dried-up riverbed covered in weird, rusty circles they're calling leopard spots. According to a scientist from NASA, these spots might be leftovers from ancient life forms that lived there billions of years ago. And now, experts think they might know what those tiny Martian critters could have looked like. Once again, we're not speaking about creatures with eyes or tentacles here. Mars is a wild place. It gets roasted during the day, then drops to minus 225 degrees Fahrenheit at night. There's low gravity and nasty radiation there, so anything living out there would have been microscopic, bacteria-level small. If, and it's a big if, something more complex ever evolved on the red planet, it would have needed insane superpowers to survive those conditions. Anyway, while cruising around an area called Bright Angel, Perseverance spotted those leopard spots. Scientists call them reaction fronts, basically places where chemical stuff went down long ago. The rover found 2 minerals in these spots, vivianite and greigite. On Earth, vivianite shows up when organic stuff rots, and greigite is made by microbes, tiny living things. One of the scientists on the team said those minerals look exactly like the kind we find when microbes are involved here on Earth. In his words, this could be the most convincing evidence of life on Mars so far. Of course, there was still a chance these patterns had been made by non-living processes. Nature could have been doing its thing without any help from space germs. But after a year of tests and reviews, and probably a lot of coffee, the team says they're confident this could be a real biosignature. So, what would this Martian life even look like? You see, today, Jezero Crater, a big impact basin just north of Mars's equator, is basically just a dusty wasteland. But billions of years ago, that place was full of water, a real Martian pond. Scientists think that the crater back then had cold, water-rich spots that were perfect for little microbial life. Those microbes could have munched on stuff like carbon, sulfur, and phosphorus in the rocks, and the minerals they produced could be what we see today as those leopard spots. Now, even though the surface conditions on Mars were insane, with freezing temps and all that radiation, microbes could still make it work, just barely surviving day to day. Experts point out that there was actually liquid water at that time, so it means the red planet was technically habitable. Now, since all we've got are these tiny traces, we can't say exactly what Martians look like or how they acted. But we can make some educated guesses by looking at Earth. We could compare the microbes from Mars with extremophile bacteria on our planet, those tough little guys living in salty lakes, deep underground, or in deserts so harsh even cacti wouldn't bother. Another question is, could anything bigger or fancier than microbes have ever evolved on Mars? Probably not. If those leopard spots are actually signs of life, scientists think microbes weren't just hanging out in one spot. They were likely all over the place. Perseverance is checking out ancient rocks beyond Jezero Crater to see if Mars had a bigger population. But here's one thing. Mars got harsh very fast. Life may have popped up on this planet around the same time as on Earth. But after about 1 billion years, the red planet started losing its atmosphere thanks to solar winds. That turned Mars into a freezing, dry wasteland. The extreme cold, radiation from the sun, and lack of water would have made it super tough for anything bigger than microbes to survive there. Complex life, like animals, took another 3 billion years to appear on Earth, and conditions on our planet were way more pleasant. If anything more advanced ever showed up on Mars, it would have had to be like a superhero microbe with thick skin or an ability to hide underground to dodge UV rays and survive in freezing temperatures. It would have been living off whatever tiny puddles of water it could find, basically like desert lizards or those weird filter feeders you find near Earth's hydrothermal vents. Now, we might still need to wait before we meet a real Martian resident, but nothing can keep our imagination from wandering. So, how about we sneak a peek at what the inhabitants of other planets of the solar system would look like if they existed and were more complex than microbes? Now, if it was a creature from Jupiter, it would probably be something like a deep-sea tank bug with a thick armored shell, huge googly eyes, webbed claws, and gills. All those features would help it survive Jupiter's crazy high pressure, radiation, and endless liquid layers. Because on this planet, at first, everything is just clouds. But go deeper, and gas turns into a liquid ocean of metallic hydrogen. No wonder locals would need all the protection they could develop. Let's jump over to Saturn with its clouds, rings, and more clouds. This planet is so light it could literally float in a giant cosmic bathtub. Here you'd likely come across a giant space jellyfish. It'd float through thick fog with an umbrella-shaped body and long tentacles instead of arms. Saturn's pressure is huge, and having a skeleton would just get it squished. Floating and flopping around is the smartest survival hack here. Now we're going to visit the ice giants, Uranus and Neptune. Both planets are like cosmic slushies of ammonia, methane, and water. Boy. There's no solid ground anywhere, just icy oceans under thick atmospheres. Here, you might meet a stocky, muscled amphibian with stubby limbs, webbed fingers, and scaly skin. All because gravity on the ice giants is higher than on Earth, and the environment is freezing. Any creature living there would need short, strong limbs to survive crushing pressure, swim through icy oceans, and stay warm. Moving back to our neighborhood, the first stop is Mercury. The sun here is so close, it looks 3 times bigger than on Earth. Temperatures swing from instant frostbite to literal oven. If anything could survive here, it'd probably have titanium skin. It would be smooth all over, and sunglass-like eyes would protect it from ultra-bright solar rays. The thing is, Mercury has almost zero atmosphere and intense sunlight. Anything living there would need a body capable of surviving heat and radiation without melting or burning out. Our final stop is Venus. The pressure there feels like you're a mile underwater. Volcanic eruptions are popping off all the time, and the air could melt lead. Tropical. And life forms here would be downgraded to a microscopic blob. No arms, no legs, and certainly no face. Venus is insanely hostile, crushing pressure, molten hot temperatures, and toxic gases. Only tiny microbial life could probably survive here. Given all that, I'll take Hawaii instead. To say space is harsh is, well, an understatement. It's filled with creepy things. What about gamma ray bursts that could cancel your existence, and mine too, on our planet tomorrow? Or mysterious, eerie, empty supervoids that are up to no good either? Which one scares you the most? Well, let's watch and pick, huh? And the first scary thing on our list is space junk. Look up there at the night sky. You might think you see stars and a few satellites, but there's something else up there, a mess of space junk, and it's growing. Earth's orbit is our highest trash dump. Old satellites that don't work anymore, empty rocket parts, and thousands of broken pieces are all flying around the planet. And they're moving insanely fast, so fast that even a tiny fragment can hit with the force of an explosion. Right now, we're tracking over 30,000 objects in orbit, and that's just the big stuff. There are millions more pieces too small to see, but still dangerous. In space, even something the size of a marble can cause serious damage. Still, extreme planets are even spookier. In our own neighborhood, some planets are kind of overwhelming. Mercury can reach about 800 degrees Fahrenheit. Venus is even hotter at 860 degrees, thanks to its thick, heat-trapping atmosphere. For reference, the Sun's surface is around 10,000 degrees Fahrenheit. But that's nothing compared to Kelt 9b, the hottest planet ever found. Its temperature soars to roughly 7,800 degrees. That's hot enough to rip atoms apart. Under conditions like that, Mercury would vaporize into glowing plasma. At the opposite end is a planet nicknamed Hoth. It's about 5.5 times Earth's mass and sits at around minus 370 degrees, just barely above absolute zero. Even though it orbits a star, that star is a dim red dwarf, so the planet gets almost no heat. Size-wise, Jupiter dominates our solar system. This gas giant outweighs all the other planets combined. But this planet, I'll let you read its name, is on another level. It's about 28 times Jupiter's mass, a big boy. It's so huge that scientists think it might actually be a brown dwarf, a failed star that almost ignited nuclear fusion. And then there's Venus, our solar system's climate nightmare. It's similar in size to Earth, but wrapped in crushing air that's nearly 1,000 times denser than ours. Winds there race at over 220 miles per hour. Sulfuric acid rains from the clouds, and the surface pressure would flatten you instantly. Sounds terrifying, but only until you hear about supernovae. A supernova is the most powerful explosion we've ever witnessed. It's what happens when a star ends its life in a massive, blinding blast that can briefly outshine an entire galaxy. So, what causes it? One type of supernova happens when a very large star, at least 5 times heavier than our Sun, runs out of fuel. While it's alive, the star stays stable because two forces are fighting against each other: gravity pulling inward and energy from nuclear reactions pushing outward. But once the fuel is gone, that outward pressure disappears. Gravity instantly takes over, and the star collapses in on itself in seconds. The collapse creates huge shock waves that blast the outer layers of the star into space. It's rather intense. But not as intense as colliding galaxies. You see, galaxies are bound by gravity and are constantly moving. That's why collisions are common, especially between large galaxies and their smaller companions. When a small galaxy drifts too close, the larger one's gravity ruthlessly pulls it apart, robbing it of its stars and gas and absorbing them completely. When galaxies of similar size collide, the outcome is even more destructive. Their spiral structures are torn apart, and neither galaxy keeps its original shape. Well, this sounds impressive, even by universal standards. And still, gamma-ray bursts are even more menacing. Those are the most powerful explosions in the universe. In just a fraction of a second, a menacing star many times heavier than our Sun collapses into a black hole. As it does, the star's outer layers are ripped away, and 2 narrow beams of energy blast out in opposite directions. These beams are so bright, we can detect them from billions of light-years away. In that minuscule instant, a gamma-ray burst releases more energy than the Sun will produce over its entire lifetime. It's not just a supernova, it's a supernova. Now, gamma-ray bursts are rare, but they're incredibly dangerous. Astronomers estimate their destructive effects could stretch across thousands of light-years. If one were to occur within about 5,000 to 8,000 light-years of Earth, the consequences would be catastrophic. One side of the planet would get flooded with deadly radiation. The ozone layer would be badly damaged or completely destroyed, leaving life exposed to intense radiation from space. The result would be a mass extinction, on the same scale as the asteroid that wiped out the dinosaurs. Now, we're approaching something even scarier. Something most of us are too afraid to imagine. I mean, other civilizations. What if they find us? There's something called the dark forest idea. Imagine the universe as a pitch-black forest. Everyone's hiding. If one civilization makes noise, another, far more advanced, might wipe it out instantly, not out of cruelty, but out of fear. In a place this big, staying silent might be the safest move. Another alarming idea. What if a super advanced society wouldn't even see us as people? We'd be more like trees in a forest or fish in the ocean. Planets could just be raw materials, and life could be perceived as just a byproduct. There might even be civilizations so advanced they could use the energy of an entire star or even a whole galaxy. At that level, erasing a planet like Earth wouldn't take effort. Thinking about it is a little unsettling. Even more unsettling is considering the existence of supervoids. Those are some of the most mind-boggling structures in the universe. Imagine a patch of space so empty it's missing roughly 10,000 galaxies. It's cold, vast, and almost completely devoid of matter. A supervoid doesn't fit into our current models of the cosmos, and scientists often describe it with the word unthinkable. But it's not completely nothing. A few lonely galaxies drift inside, which is somehow even more sinister than total emptiness. The edges of the void aren't smooth. They have temperature shifts and subtle changes that hint at some invisible forces. Even light seems to get distorted there, making these regions super eerie. But the worst part is that some supervoids can impact us. For example, something strange is moving our galaxy through space at about 1.2 million miles per hour. In front of us, a massive cluster of galaxies, called the Shapley concentration, 650 million light-years away, is pulling us toward it. And behind us, scientists discovered a nearly empty region of space with almost no galaxies. They call this supervoid the dipole repeller, and it's shoving the Milky Way with incredible force. But it's probably better than being propelled toward a black hole. Black holes are some of the universe's most ruthless objects. They can swallow asteroids, comets, planets, and even stars. Almost every black hole starts its life as a massive star. Then it runs out of fuel, it collapses in on itself, and packs more mass into a tiny space than you can imagine. That's why its gravity is so insane even light can't escape. A lot of people picture black holes as giant cosmic vacuums, pulling up everything around them. But that's a myth. Black holes can only pull in stuff that gets super close, crossing what's called the event horizon, a point of no return. For a black hole with the mass of our Sun, that boundary is just about 2 miles across. And for a black hole as small as Earth, the event horizon would be just a couple of inches wide. Still, their gravity is powerful enough to influence stars and planets nearby. And now, we're finally ready to speak about the ultimate nightmare the human brain simply can't comprehend: the sheer size of the universe. Imagine this. You're sitting in your room. That room is inside your house. Your house is on Earth. Earth is part of our solar system, which has 8 planets. And that solar system is just one tiny neighborhood inside the Milky Way galaxy, home to at least 100 billion other planets. Now, it is getting wilder. The Milky Way is just one galaxy in a local group with few others. That group sits inside the Virgo supercluster, which contains hundreds of galaxies. And all of that is just a small part of the observable universe, which stretches about 93 billion light-years across. And that's only what we can see with our current tech. We have no idea how much bigger the universe actually is, or if it even has an end. Think about that. Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth, but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers use different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth, it's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on this super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet.
In the heart of the galaxy, there lies a mysterious Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man, with his repulsor beams on full blast. Now technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole, beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole. And that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole. but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? Maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now that would be awesome.
Oh, fasten your seatbelts. We're setting course for the most bizarre places in our universe, and you'll see the most mysterious phenomena few people have ever seen before. Recently, astronomers have discovered that the supermassive black hole at the center of our home Milky Way galaxy might be leaking. Why is it a significant change? Because it might mean that this black hole, called Sagittarius A star, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active, and the leakage recorded by scientists may be the hole hiccuping while swallowing clouds of gas. Hey, I've been known to do that from time to time. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often occurs around other active black holes surrounded by the material drawn to them by their immense gravitational pull. Some of this material gets pulled into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches small jets of matter. Fermi bubbles might be the result of the belches that occurred around 2 to 4 million years ago. But recently, scientists have found another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light-years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now, let's visit some other breathtaking places in our universe. But be careful, some of them are extremely dangerous. Like this rotating neutron star called the Black Widow pulsar. Just like its spider namesake, it's munching on its partner, a lightweight brown dwarf star. The more material this pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. How about visiting a planet where it rains glass? Nah, I'd rather not. You see, this bright blue exoplanet looks peaceful and slightly familiar. Don't you think it slightly resembles Earth? But this pretty appearance hides the planet's terrifying nature. The winds blow at 5,400 miles per hour on its surface. That's 7 times the speed of sound. But that's not the worst. It rains glass sideways in this scorching hot alien world. Solar tsunamis are a solar phenomenon dubbed Terminator events. These tsunamis take place at the sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen every decade or so. Now look at this space body. Its nickname is Electric Hyperion. This Saturn's moon is one of the most bizarre-looking moons in the solar system, but its appearance isn't the strangest thing about it. This pumice stone-like rock, pockmarked with countless craters, is also charged with static electricity, and it's flowing out into space. Look at this, a rogue planet with auroras. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars. But one of them, 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates flashing auroras in the planet's atmosphere. Be sure to stay away from black holes. Do I really need to warn you? Yep, they're some of the most perilous objects in the universe. But how about mini black holes? Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 sedans. One theory claims that tons of micro-black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. Ooh, I'll bet you like our next stop, a burning ice planet. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means it's traveling remarkably close to its parent star. That might be the reason the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X, which remains solid despite blistering temperatures. Now, if you love jewelry, this next world is for you, a diamond planet. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. This in turn might mean that at least some part of the planet is diamond. Moons orbiting other moons might exist, or they might not. Astronomers haven't agreed on this one yet. Planets orbit stars, and moons orbit planets. But then, why can't there be moons, also known as submoons, moonettes, and moons? It actually sounds like one of those flowery Hawaiian dresses, muumuus. But alas, no. Researchers claim that moons could exist, but the host moon has to be massive enough, the moon small enough, and there must be a wide gulf between these moons and the host planet. Now, I'll take you to the living fossil galaxy. DG-SAT-1 is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DG-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, this galaxy is a real living fossil. Now, you won't be able to see the next space phenomenon, all because people can't see infrared light. And the phenomenon I'm talking about is an infrared stream from space. Ooh. Neutron stars are ultra-dense collapsed cores of giant stars. They usually emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. This signal was probably generated by a disk of dust surrounding the star, but this theory hasn't been proven yet. Behind the orbit of Neptune lies the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding from our sight a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. Let's visit our star, but we need to be careful not to come too close, because the Sun's atmosphere is hotter than the surface of the star. While on the surface, the temperature reaches 10,000 degrees Fahrenheit, the upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the Sun may have something to do with this unique phenomenon. Now, this space object is also worth visiting. Haumea, a dwarf planet orbiting in the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning big object in our solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile wide ring circling it. Ring-a-ding-ding.
Jupiter is the largest planet in the solar system. More than 1,300 Earths could fit inside this gas giant. It's also 2.5 times more massive than all the other planets of the solar system combined. But if you think this is mind-boggling, I've got some great news for you. Very recently, a team of astronomers has discovered a much bigger planet with the help of the Subaru telescope and the NASA Hubble Space Telescope. It's a Jupiter-like protoplanet orbiting a very young star called AB Aurigae. The star is probably still forming and is no more than 5 million years old. For comparison, our Sun is 4.6 billion years old. The young star is located around 531 light-years away from Earth in the constellation of Auriga. The star is shrouded in a thick, quickly moving layer of gas and dust. This disk feeds the growth of the star. Later, what is left of this disk will come together to form the elements of the planetary system: planets, dwarf planets, comets, asteroids, you name it. But back to the newly discovered planet. It's a gas giant whose mass equals that of 9 Jupiters. Can you imagine this colossus? It takes the planet, named AB Aurigae B, almost 588 Earth years to complete just one journey around its parent star. Maybe because it's 93.9 AU, astronomical units, away from it. Now, why is the discovery of this planet so amazing? Because according to astronomers, it's been forming in a very bizarre way. Or should I say, IS forming, since this gas giant is still in the process. Anyway, the unusual thing is that AB Aurigae B is coming together as a result of a top-down gravitational collapse of giant clouds of gas. But scientists say that a much more common model of planetary formation is when dust and rocks gradually accumulate around some kind of core. This proves the idea that there are numerous ways for planets to form. It can also mean that there probably are very diverse planetary systems in our home Milky Way galaxy. But AB Aurigae B isn't the largest exoplanet ever discovered. In 2005, astronomers spotted a mysterious space body. Later they called it GQ Loopy b. The thing was orbiting a young star at a distance 2.5 times greater than that between the Sun and Pluto. Scientists came to the conclusion that the object was either a planet or a brown dwarf, which is basically a tiny star. If astronomers decide that GQ Loopy b is a planet, it will be the largest ever found, with a radius that is 3.5 times that of Jupiter. The biggest star we know about is called UY Scuti. This hypergiant has a radius that is about 1,700 times greater than that of the Sun. If you somehow managed to place UY Scuti in the center of the solar system, its edges would stretch far beyond Jupiter's orbit. As for the dust and gas streaming from the star, all this would extend beyond the orbit of Pluto. That's 400 times the Sun-Earth distance. A black hole is a spot in space where the pull of gravity is so strong that even light can't escape it. But why is gravity so powerful there? Because matter is squeezed into a teeny tiny space. Supermassive black holes, which can be many millions of times the mass of the Sun, tend to lurk in the centers of galaxies. The most massive black hole astronomers have discovered so far is TON 618. Its mass is equal to that of 66 billion suns. It was the year 2010 when, with the help of the Fermi telescope, astronomers spotted ginormous something entering the Milky Way. Their discovery looked like massive blobs of matter that could only be observed in particular wavelengths of light. They were also about 25,000 light-years tall. Scientists think that the blobs, called Fermi bubbles, could be produced by our galaxy's central black hole. Space seems to be extremely deserted, but some places are even emptier than the rest, like Supervoid and Eridanus. Astronomers noticed this huge region of empty space in 2004. The area stretches 1.8 billion light-years across. It's mysteriously devoid of gas, dust, stars, and even dark matter. A nebula is a massive cloud of gas and dust floating in space. Some nebulae form when a star is nearing the end of its life and throws out loads of gas and dust. Others appear in regions where new stars are forming. The largest nebula we know about is the Tarantula Nebula. In its longest span, it measures over 1,800 light-years. This nebula, also known as 30 Doradus, is located around 170,000 light-years away from Earth. Unlike its namesake, the tarantula isn't dangerous. Quite the opposite. It's a stellar nursery, which means it's a region where tons of young stars are born. Even cooler, it's the most active star-forming area in our entire galactic neighborhood. In 2021, the biggest ever comet we know about entered our solar system. It was 85 miles across, and its icy nucleus was 50 times greater than the nucleus of the previous record breaker. The intruder's mass was a whopping 100,000 times bigger than that of an average comet. In fact, C-2014 UN-271 Bernardinelli Bernstein was so large that astronomers first classified it as a minor planet. Is it going to crash into Earth? Nah, it won't get closer than 1 billion miles to our beautiful green planet, and it won't happen until 2031. But could there be comets even bigger than that? Who knows? But the thought is terrifying. There are loads of bizarre things in the universe, and hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but only if you apply 10 billion times the pressure needed to shatter steel. Pulsars are spherical space objects the size of a large city, but they pack more mass than the entire sun. They radiate 2 narrow beams of lights, sending them in opposite directions. The Black Widow pulsar, just like its spider namesake, is munching on its partner. It's a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes its companion star to dwindle. Haumea is a dwarf planet orbiting in the Kuiper Belt, a donut-shaped ring of objects around the Sun that extends just beyond the orbit of Neptune. The mini-planet has a bizarre elongated shape and 2 moons. The day on this planet lasts just 4 hours, which makes it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile wide ring circling it. What is it? Where did it come from? No one knows. Could be the result of a collision that happened in the distant past. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because of a ring of dust and debris circling it. It makes the star look like a giant eye staring into your soul. The intimidating star is more than twice the mass of the Sun. It's 25 light-years away from Earth, which isn't that far away considering distances in space. Look at this butterfly. Its wingspan is more than 3 light-years, and the structure inside this nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an incredible 450,000 AF. It means it was formed from another gargantuan star more than 5 times the size of the Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly.
Well, I hate to break it to you, but I'm told that our Earth might not be so special after all. Scientists say it could just be the last planet in our solar system that hasn't moved on yet. Yep, the worrying part is that it looks like planets don't stay Earth-like forever. They pass through it. Atmosphere, liquid water, internal heat, magnetic shields – all that lines up for a while, and then, slowly, it unravels. Now, for a long time, scientists treated Earth-like planets as cosmic unicorns, 1 in 100 star kind of rare. But when they ran updated models with better physics and geology, researchers realized that if the conditions line up, Earth-like planets with liquid water could exist around almost every star. Not 1 in 100, potentially 1 per star. That's 100 times more common than they thought. Our Milky Way alone has at least 100 billion stars. Hey, suddenly the universe doesn't feel empty at all, and planets don't even need oceans splashing on the surface to count. Many worlds that look frozen on the outside could be hiding liquid water deep below their crusts, quietly warm and stable. It's already happening in our own backyard. Moons like Europa and Ganymede around Jupiter and Enceladus around Saturn look like icy balls from space, but underneath their cracked shells there are global saltwater oceans. Even dwarf planets like Pluto and Ceres show signs of buried water. The secret sauce is heat. Radioactive elements inside a planet slowly release energy, like a tiny heater that never shuts off. Plus, gravity from nearby giant planets stretches and squeezes these worlds and creates friction heat. So, it seems pretty easy for Earth-like planets to form. And if you look at modern planet formation models, you'll see rocky planets like ours pop up all the time. It's possible that the early solar system didn't just make one Earth. It made several attempts. Mercury, Venus, Earth, and Mars all formed from the same neighborhood, same materials, same chaos. Exploding stars nearby, called supernovae, sprayed heavy elements like iron and nickel into the cloud that became our planets. That gave them solid cores, internal heat, and the potential for magnetic fields. That's the starter kit for an Earth-like world. So instead of Earth being a miracle, it starts to look like the survivor of a group project where everyone else dropped out. Now, Mars is the first planet in this dropout group that has been actively giving away clues that it wasn't always the dry, rusty place we see today. Scientists have spotted river deltas, minerals that only form in water, and landscapes that look carved rather than blasted. All signs point to the same thing: Mars used to be wet. The big question was never if there was water, but what kind of world it created. Was Mars frozen with bursts of melting ice, or was it warm enough to hold long-lasting oceans? New evidence tips the scale towards something huge. Around 3 billion years ago, Mars likely had a massive ocean covering most of its northern hemisphere. It was not a patchwork of lakes, but one connected body of water. That idea comes from studying the biggest canyon system in the solar system. It stretches about 2,500 miles long and up to 120 miles wide, dwarfing Earth's Grand Canyon by comparison. There is an area inside the canyon where signs point to a deep ancient lake. Scientists found special layered deposits along the canyon walls that show rivers once flowed into the canyon. Even stranger, all these deposits sit at almost exactly the same height. That tells us the water level stayed stable for a long time, and depths reached nearly 3,300 feet in some places. The canyon floor sits higher than Mars's northern lowlands. If water filled the canyon that deeply, it had to spill outward, flooding the entire northern half of the planet. In other words, Mars wasn't just wet, it was blue. This discovery comes with a warning. Mars shows how precious water really is and how easily a planet can lose it. It looks like Mars didn't fail because it was weird or flawed. Studies now show its core stayed hot and solid for a long time, very Earth-like in structure. The difference is in size. Mars is smaller, so it cooled faster. Once the core slowed, the magnetic field weakened. Once the field weakened, the atmosphere started leaking into space. It's like trying to hold water in a bucket full of tiny holes. Eventually, gravity loses the fight. Alright, and what about Venus and its potential for life? It has always looked like Earth's evil twin: poisonous air, crushing pressure, surface hot enough to melt lead. But NASA's Magellan mission back in the early 1990s collected some data that tells a completely different story, one where Venus might still be alive on the inside. Magellan arrived at Venus and did something no spacecraft had done before. It mapped the entire planet's surface and gravity field in detail. At the time, scientists mostly used the images to catalog craters and strange landforms. But now, with better models and computing power, researchers are rereading that data and realizing Venus may be far more geologically active than anyone assumed. The biggest clue comes from massive features called coronae. These are large, almost circular formations that can stretch dozens to hundreds of miles across. It's like a giant blister in the planet's crust. Venus doesn't have moving tectonic plates like Earth, but that doesn't mean nothing moves. Hot, buoyant material from deep inside the planet, the mantle, can push upward, warping and cracking the surface from below. When they combined Magellan's gravity data with its topography maps, scientists managed to peek beneath Venus's crust. They noticed hidden mantle plumes, rising columns of hot rock that don't always show up in surface images alone. Around some coronae, researchers even found signs of subduction, where one section of crust sinks beneath another. Plus, something called lithospheric dripping, where dense surface material slowly sinks back into the mantle like cooling wax. Now all this sounds cool, but it starts feeling way more personal when you find out Earth may have looked like this once. Coronae don't exist on modern Earth, but they might have formed billions of years ago, before plate tectonics fully took over. Studying Venus today could be like looking at a snapshot of Earth's deep past. And this is just the warm-up. NASA's Veritas mission will return to Venus with modern radar, build 3D global maps, analyze surface chemistry, and measure the planet's gravity field in far greater detail, up to 4 times sharper than Magellan. If Venus is still shifting, dripping, and churning inside, Veritas will catch it in the act. Now, Venus isn't the only planet getting a second look thanks to dusty old data files. Back in 1986, Voyager 2 flew past Uranus and sent back a snapshot that confused everyone. Uranus looked like a cold, tilted, icy giant wrapped in one of the strangest magnetic bubbles ever seen. Its magnetosphere, the invisible magnetic shield around the planet, made no sense. It was tilted by about 59 degrees, shoved off-center inside the planet, and paired with a planet already lying on its side at a 98-degree tilt. Even weirder, Voyager 2 found that Uranus's magnetosphere was almost empty. Very little plasma hung around inside it. Instead, scientists saw dense belts of high-energy electrons, packed way tighter than expected. For decades, researchers assumed this was just how Uranus worked, a permanently broken magnetic system. But now, they reanalyzed Voyager 2's data with modern tools and decades of new knowledge about space weather. And it looks like Voyager 2 didn't catch Uranus in its normal state at all. It caught it when a solar storm was passing Uranus. So Uranus might not be permanently weird. And since our entire understanding of Uranus is based on a single flyby during a cosmic storm, it could be hiding plenty of secrets. Put all this together, and the solar system starts to look less like a tidy family and more like a graveyard of transformed former Earths. And when scientists say Earth isn't a planet type, but a phase, they're not just being dramatic. Earth just happens to be the last one in the solar system still holding the line.
Look at this fascinating planet. It looks as if it's burning. It must be hotter on its surface than in the middle of Death Valley. The ground is parched, cut by giant cracks. There's not a drop of water in this boiling world. Now, it's the same planet, but it looks like a totally different place. Everything is frozen. The temperatures are so low, there isn't even a tiniest chance that life could survive on this planet. This bizarre world is called HD 20794d, and it's located 19.7 light-years away from Earth in the constellation Eridanus. This planet is a super-Earth. This term means that it is larger than Earth but smaller than such ice giants as Neptune. What makes this planet especially interesting is its unusual orbit, which moves it in and out of its star's habitable zone, the region where temperatures might allow liquid water to exist. Now, we haven't seen this unusual planet directly. Astronomers detected it by measuring tiny wobbles in its star using two powerful instruments, espresso and HARPS, located at telescopes in Chile. These instruments measure radial velocity, which is the small movement a star makes as a planet's gravity tugs on it. The larger the wobble, the more massive the planet. Later, astronomers analyzed the data and figured out that the planet in question has a mass around 6 times greater than Earth's. It orbits a star, which is slightly smaller and dimmer than our Sun. What makes this star unique is that it is bright enough to be seen with the unaided eye, unlike many other stars that host exoplanets. You won't be able to see them without a telescope. The star system has been observed for over 20 years. Astronomers have long suspected it had multiple planets. In 2011, scientists discovered 2 other super-Earths orbiting the star every 18.3 and 89.6 days, respectively. For some time, researchers thought they had found a third planet with an orbital period of 40 days. Later, they realized they had made a mistake. But recently, after reanalyzing years of data, astronomers have confirmed that the third planet does exist, and it's our extreme HD 20794d. A researcher from the University of Oxford played a key role in identifying the planet. He used a special computer algorithm called Yarara to separate the planet's weak signal from the background noise. It helped him confirm that the planet truly existed and was pretty unique. Unlike the planets in our solar system, which have mostly circular orbits, the newly discovered one follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one trip around its star. That's just 40 days shorter than Mars's orbit around the Sun. At its furthest point, the planet is twice the Earth-Sun distance, which makes it an icy world far outside the habitable zone. At its closest point, it moves inward to 0.75 AU, where it enters the habitable zone, where liquid water might exist. This extreme movement creates truly bizarre seasons. For some part of its orbit, HD 20794d is frozen, like an icy wasteland. As it approaches its star, temperatures rise and ice likely melts, forming temporary oceans. The planet then experiences a short, scorching summer. It is so hot that the water on its surface might evaporate into the atmosphere. Shortly after, the planet moves away again. It triggers a gloomy fall with rains, followed by a deep freeze in winter. In other words, the planet switches between extreme cold and intense heat, which makes it a very unpredictable place for life. If any life forms exist there, they certainly need to adapt to dramatic changes in temperature and environment. Why does the planet follow such a mind-boggling orbit? It might be a leftover effect from events billions of years ago, when the planetary system was still forming. At some point, another large planet may have disturbed the orbit of our extraordinary friend. Another possible explanation is that a giant planet once existed in the system, and its gravity pushed HD 20794d into an elongated path. Later, this giant planet may have been ejected from the system, leaving the smaller planet in its current orbit. This theory makes sense because the 2 other planets in the system, B and C, have more normal circular orbits. The discovery of this planet is so exciting because it challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD 20794d only passes through it. Scientists want to know if such a planet could still support life, even briefly. So future telescopes will study the atmosphere of this planet, looking for signs of water, gases, or even life. Another super-Earth that might have the right conditions for life orbits a star 137 light-years away. In space terms, this is considered relatively close. A light-year is around 6 trillion miles. The planet is called TOI 715b, and it's about 1.5 times the size of Earth. Unlike HD 20794d, it's permanently located in the habitable zone. Look, that's what astronomers think the planet might look like. TOI 715b orbits its star very quickly, completing a full orbit in just 19 days. But even though it's close to its star, it may not be extremely hot, all because its star is a red dwarf. That's a type of star that is smaller and cooler than our Sun. This means TOI 715b could have a milder temperature compared to other exoplanets that orbit closer to hotter stars. NASA discovered the planet using the Transiting Exoplanet Survey satellite. This space telescope finds planets by watching for small dips in a star's brightness, which happen when a planet passes in front of it. Since red dwarfs are smaller and dimmer than the Sun, planets passing in front of them are easier to detect. Astronomers are planning to study the planet further using the James Webb Space Telescope. This powerful telescope, located 1 million miles away from Earth, can analyze the atmospheres of distant planets. If TOI 715b has an atmosphere, JWST could help scientists determine what gases are present in it and whether such conditions could support liquid water or even life. One more promising world for our search for extraterrestrial life is an extremely dense super-Earth in the K2360 system. An international team of researchers from Japan and Europe has discovered this remarkable multi-planet system orbiting a Sun-like star located 750 light-years away. This system has 2 planets, including one of the densest rocky planets ever found. The K2360b is a rocky super-Earth, about 1.6 times the size of Earth, but with a mass 7.7 times greater. This makes it as dense as lead. The planet orbits its star incredibly fast, completing one full orbit in just 21 hours. It's the densest known ultra-short period planet with well-measured properties. As for its sibling, this is a much larger outer planet with at least 15 Earth masses. It takes 9.8 days to orbit its star. Sadly, since it does not pass in front of its star from our viewpoint, scientists cannot determine its exact size. The unusually dense planet might be the core of a much larger planet. Over time, intense radiation from its parent star may have blown away its outer layers, leaving behind only its dense, rocky core. So, in fact, this planet could show us what might happen to some planets that are too close to their stars. Astronomers think that the planet may have moved inward over time due to interactions with its larger companion planet. One possibility is high eccentricity migration, where a planet's orbit becomes highly stretched out due to gravitational interactions before gradually becoming more circular near the star. Another theory is that the planet's spin and axial tilt can cause its orbit to become more circular. Such planets are rare, and finding one with a massive outer companion can help scientists refine their theories about how planets form and evolve in extreme environments. With its help, we might also understand how rocky planets evolve and what happens to planets that get too close